Good afternoon everyone, and welcome to another worked exam answer video. I'm having a look in this video at a fractional distillation of crude oil GCSE question, and I've chosen this particular question because explaining how we get different fractions from the crude oil by fractional distillation is a very common longer mark answer where I imagine it can feel quite daunting to know what to write. I imagine it's one of those where we know what the fractional distillation column, or the fractionating column rather, looks like, and we understand that we go from crude oil to the different fractions of the crude oil, but trying to explain that concisely can be quite difficult. But I'm here with good news, because every single time we're asked how we separate crude oil, it will be the same marking points that they're going to want you to put. Now, in this particular question, they've even told you that it's by fractional distillation. Occasionally they won't tell you that, and you'll get an extra mark for naming the process as fractional distillation. So we're told that crude oil is separated into fractions by fractional distillation, and then they've given us in this particular question, which is an AQA question, the fractions obtained from crude oil can include lubricating oil, naphtha and petroleum gases. Different specs might expect you to know different fractions that we can get from crude oil. For example, if you're studying the EdXLI GCSE, you wouldn't need to know any of those fractions, but for this particular question, it's the method of fractional distillation that we're considering, so that method never changes, so that's the same across the specs. We've then got the boiling point ranges of the fractions. Now, something that can cause confusion is how can we have a boiling point range if we've separated the crude oil into these three things? And that comes from the fact that within these three fractions, we will have molecules of slightly different length of chain. And that's because of the spacing between the sort of collection pipes, or the kind of collecting areas within the column that we then use to help us to pipe off the different fractions. Within the gap between them, there will be a number of molecules that will condense in that change in temperature, and therefore we will have a little mixture of different molecules within the lubricating oil fraction. The length of those molecules will be incredibly similar, but therefore we have a boiling point range, not just a specific boiling point. And if it says boiling point range, it would be good to kind of maybe use that terminology in our answer as well. So we can see here that the petroleum gases have a boiling point range of less than 25, so they don't actually recondense back into liquids, they stay as gases. Then naphtha and the different molecules in the naphtha fraction have a boiling point range of 90 to 200, and then the lubricating oil is 300 to 350. Now, we don't need this for this question, but we do need to know which of these we'd find at the top of the fractionating column, which would be the petroleum gases, ironically, and then the lubricating oil out of these three would collect nearest the bottom. And that's based on, again, the size of the molecules, the boiling points of the molecules, and the temperature gradient over the column. So we have to explain how these fractions are obtained from the crude oil by fractional distillation, aka how does fractional distillation work? Okay, now there's 4 set marking points that we need to include, and this applies for every single question. Occasionally this might be worth 5 marks, in which case it might say explain how the naphtha fraction is obtained, and then you would have to make some specific reference, for mark 5, to the naphtha fraction, something along the lines of here how its boiling point range compares to the other two, and roughly where you would find that in terms of position up the column, something along those lines. But here we're just very generically stating how fractions, whichever fractions they might be, are obtained from crude oil by fractional distillation. So the first thing that happens is the crude oil, which is a liquid, needs to be heated, and it's always heated outside of the fractionating column, and that's really important as well. It doesn't get pumped in as a liquid and then get heated up inside. The whole of the crude oil is heated to the point where it's all a gas, and then it's the vapours that go into the column. So step number 1 will be that the crude oil is heated and the vapours are trying to think of a good way of saying the vapours are they go into, but trying to think if there's a scientific way of saying that. The crude oil is heated and the vapours are I'm going to put piped because I can't think of a better word, into the fractionating column. So that always has to come first. It doesn't happen when we're inside the column, it happens outside of the column, and every different fraction within the crude oil will be a gas when it enters the fractionating column, sorry. The reason why we need it to be a gas is because we are relying on the different fractions condensing at different points, which we'll come on to for some of our later points. So that's why everything needs to be a gas in the first instance. The second thing to say is that there's a temperature gradient over the fractionating column. And we need to know that it's hotter at the bottom and cooler at the top. And that's important because when the different fractions and the molecules for those fractions get pumped into the fractionating column, the larger ones that have higher boiling point ranges will cool sooner, more quickly than the ones that have got really low boiling points, and the lower boiling point ones will be able to rise up the column and cool down, but will need much more cooling to happen because they have much lower boiling point ranges, whereas the ones with the greater boiling point ranges, they won't rise very high at all before they condense. Or bitumen isn't on here, but bitumen being the fraction that we get out of the very bottom of the column, it's got the largest molecules in there with the highest boiling point range. Those molecules will pretty much go into the column and then condense straight away. But because they condense at different heights, because they rise up the column to differing degrees, that means we can collect them at different points, and that is fundamental, and the temperature gradient helps to achieve that. So step 3. The fractions rise up the column by varying amounts and condense, which is a key word. They'll be going back into a liquid and they condense at different heights. And the reason why they condense at different heights is our final point, which is they have different boiling point ranges. So the fractions rise up the column by varying amounts and condense at different heights because the fractions have different boiling point ranges, as we can see in table 1. Now the boiling point ranges, or the boiling points of each individual molecule, that is a physical property, and occasionally it might ask you which physical property of the fractions of the crude oil enables them to be separated in this way. If they didn't have different boiling point ranges, because the fractions weren't made up of different size molecules, they wouldn't separate this way. So it's fundamental that they have different boiling point ranges so that we can get all of the different fractions out, and then we can obviously use those for very different things. So we can use the gasoline or the petroleum for petrol, we can use kerosene as fuel oil, we can use bitumen, mix it with rock chippings to tar road surfaces or roofs, etc, etc. But that is how fractional distillation works, and those are the same 4 points that they will be looking for every single time you're asked to explain how that process works. So it might be that getting that on a flashcard, or getting them on 4 different flashcards, or just having them written out somewhere, like, I don't know, if you have a revision folder, sticking it on the front of your revision folder or something like that. But if this is something that you know you find difficult, that is your stock answer for this question. So hopefully that helps. Any questions, as always, guys, please just ask, however you feel comfortable to do so. And yeah, if there's any other questions you'd like me to have a go at, please just let me know. Thank you so much for watching. Hope you're all well.